now that we've looked a little bit at the data and we want to compare these two groups, specifically, we're trying to see if it's the same or not. So we're trying to find if the mean of video only is the same or not the same as audio and visual. We really need to consider what the most appropriate way to do this is. So are the samples paired? Um, when we have a look at what the data looks like here, let me just see it again. Here, the data could not possibly be paired because there's a different amount of samples in the one column than in the other. The other reason that it doesn't make sense to pair here is because there's no natural pairing. As I said before, would this 2 go with this 6 or with this 2 or with this 3? There's no reason to think that these are the same people being given the video only and then the audio and the visual. So they're different people. There's no real way to link those two together. So here, are the samples paired? The answer should be no. Are the data normally distributed? So here, let's go ahead and make sure that we've installed Nortest. Okay, so if I try to install Nortest, then I'll go through and make sure that it's there. And I'll also load Nortest. Then once I've got Nortest package installed and loaded, then I can do the normality test for the video group. And you can see this p-value is slightly over 5%, therefore it's looking normal. And I can also do the p-value for the normality test of the audio and the visual, and you can also see that that is over 5% as well. So here I went through asking if the data was normal, and because I got relatively large p-values, at least larger than 5%, then I'm going to fail to reject, and I'm going to say they are normal. So at this point, then here I'm suggesting that these data are normal, or at least normal enough. And my next now step is to perform Levenes test. Levenes test is about if the spreads are equal. So whether you say the variances are equal or if you're saying the standard deviations are equal, here I've used sigmas. Here I've got sigma squared. So either you can write it as the variances are equal, or if you can write it as the standard deviations are equal or not equal. We have to get our data into stacked columns. So again, let me just remind you what our data currently looks like. That is two separate columns. This command here, stack, so you can stack the data that you've got in a data frame. What that does is here, actually, I guess we had three columns. We had this column of just 1, 2, 3, 4 to 18. We've got this column of video only, and we've got this column of audio and visual. And so what that did was it just put this column, and then it copied this column, and then it copied this column, and it made a new column about the titles where these numbers came from. So first we had 1 through 18, and this was coming from the column called X. Then we had the other column that was coming from the column called video only, and then we had the other numbers coming from audio visual. So that's not quite what we're looking for because we really didn't care about having this first column that was just the numbers 1 through 18. So here, if instead I use the command stack, but then I say on columns 2 through 3, you'll see I miss out on having these numbers 1 through 18, and I go right to stacking only the second and the third column here. So finally, I just have these values from those two columns specifically. I'm going to do that same command that I just did, but I'm going to now call it the letter A. So when I now press A, I can actually get these. Now to perform Levenes test, which of course is the test of equal standard deviation or equal variance, if you like to write it that way, I need to make sure that in my packages, I have a package called car installed. So I'm going to make sure that car is installed. And after car is all properly installed, of course, I need to load it as well. And now that I've got the data in a stacked format, meaning that it looks like the numbers are all in one column and then where they came from is in another column, under the car package, there is a command called Levene test. And so here in Levene test, I am going to reference this stacked column that I called A, and I'm going to say A $, these were the values, and then comma A $, these where they came from. And then here I can just press enter, and I'm going to get an F test statistic, and I'm going to get a p-value, and here are the degrees of freedom. So here, this is the F distribution, which is definitely a different distribution than either Z distribution or T distribution, which are you are used to working on. But here, the F distribution is a right-skewed distribution. It's not bell-shaped like Z or T. But at the same time, here what I'm saying is the probability of the F distribution with 1 degree of freedom in the numerator and 32 degrees of freedom in the denominator. You can see that here, 1 degree of freedom and 32 degrees of freedom. And when I've got the test statistic that I was given, the probability of being greater then that is the p-value. So here's the p-value. You use the same rules with this p-value as you do with every other p-value. Because it is greater than alpha, because it's greater than 5%, then I will fail to reject the null hypothesis. Here's the null hypothesis. So basically what I'm saying is that these standard deviations look to be similar.